Test 2 topic will be 1.7, 1.8, 2.1 to 2.5, and then 3.1. Now, your quiz that you need to turn in this Saturday for that number 1 requires extra knowledge from 3.1, which I will cover today. Okay. 2.4 still in between this, right? It's in the material. The piecewise defined function will be in your test 2. However, if I happen to cover 2.6 today, that 2.6 will not be in test 2. It will be in test 3. Now, what do we need to learn from that quadratic function? Mostly things that we already learned. Okay. Quadratic function, the general form looks like this. We already get used to it. Right? We saw that before, and the standard form looks like this. Now, let's say, for example, the one in standard form. Let fx equals to, let's say, 1/2 x minus 2 squared plus 3. Let's say we have a question like that. Okay. Our main goal is to graph this, but along the way, we will get all the possible informations about this fx. Basically, whatever we can know, we need to know. Okay. For example, the first one, what is the domain? Because it is quadratic function, it's polynomial, then the domain would be all real numbers. We know because the leading coefficient is positive and it is quadratic, then it will be a parabola opens up, right? Okay, it will be a parabola opens up. So one of the main question later on will be, what's the range? Okay, we'll need to find what's the range. I get a question here. For the quiz due Saturday, the standard form on the screen is what we will need to answer question number 1. I think that's a 1F or 1G. I think so. Yeah, it's one of them. Okay, so when we say standard form, it refers to this one. Okay, I will do one problem similar to the one in your quiz later on. Okay, after this example base, actually. Okay, so we will need to answer the range later on, the range question. But for us to find the range question, we need to find the vertex. Okay, we need to find the vertex. So we will hold on to the range until we get the vertex. Part B, how about the y-intercept? The y-intercept, we plug in x equals to 0 and compute. Sorry. X equals to 0 and compute the outcome. That's 1/2 times -2 squared plus 3. That's 1/2 times 4 plus 3. 1/2 times 4 is 2 plus 3, so that's 5. So the y-intercept is 0, 5. And then part C, how about the x-intercept? The x-intercept, we set the y equals to 0. Okay, and then you use the knowledge we have learned from your test 1, basically how to solve a quadratic equation. Okay, and try to benefit from the fact that this is a completed square. Okay, you know what? I need to change the problem a little bit. This is not nice. I want to make this -3. So I want to make this -3. -3, -3, so it's not 5. I'm sorry. -3, so this is squared -3, squared -3, 4, -3. So that's -1. The y-intercept is 0, -1. You will see later on why. Okay, so I changed this to -3. Now the reason is because what we had earlier will not have what we'll have earlier if that were a plus 1/2 x x minus 2 squared plus 3. Now, you know the vertex will be 2, 3, right? And it opens up. So you see, like from the sketch of our graph, if that were plus 3, we will not have x-intercept, right? It's still graphable. That's still graphable. But we need to argue why we don't have x-intercept separately. But for now, we know it has no x-intercept. So going back to this, suppose I change that to minus 3. So 3 equals to 1/2 x plus x minus 2 squared multiplied by 2. I get 6 equals to x minus 2 squared. And then apply square root property. Square root of plus minus square root of 6 equals to x minus 2. So 2 plus minus square root of 6 equals to x. So my x-intercepts are 2 plus square root of 6, 0. 2 minus square root of 6, 0.
Professor?
Uh-huh.
Did you multiply the denominator to both sides or something?
Yeah, basically.
All
yeah,
right.
from here, right? Multiply by 2. Because this what you see here is basically x minus 2 squared over 2. That's what it looks like, actually. That's what it looks like. So that's why I multiply by 2 both sides, right? So that we get rid of the 2 in the denominator. Okay. So we get the x-intercept. They are ugly numbers. They are irrational. That's actually irrational numbers, but still they are irrational numbers. Now, remember I said last time that some of you actually use photomath to do your tests, and I get so pissed off. Okay, please don't do that anymore. Please don't do that anymore. Okay, and trust me, your test too, you cannot survive far. You cannot go far with photomath. Okay, photomath can only do that much. Okay, and of course, in your test too, I will proctor you already, so you cannot use Zoom. You cannot use photomath anymore, right? But even if you secretly try to do that, you won't be able to do what you do here. Okay, why? There are two problems with photomath. Photomath strangely cannot do factoring in a natural way. Photomath doing factoring in they call that AC method, okay, which is not a natural way, and somehow they get a strange form. They still get the right answer, but get a strange form. Now, but when it comes to this kind of solution, your photomath will force yourself to do it in decimals, which is an approximation, therefore not the right answer anymore. Okay, photomath is an app that you can take the picture of the problem using your cell phone, okay, and then all of a sudden it gives you the solution with all the work, But the thing is, like, the work they do is very generic, such that if you use that, your work seems to be very, very unnatural. It's just like, why do you do that? Okay. Let me show you, for example. This is not the actual work, but for example, if you try to solve 3x plus 2 equals to 5x minus 6, it will do it this way: 3x plus 2 minus 5x equals -6. Then 2 minus 2x equals to -6, and then -2x equals -6 plus 2, and then -2x equals to -4, and x equals to -4 over -2, x equals to 2. Now, this seems to be makes so much sense, right? Okay, but the thing is, will the same person who does it this way able to factor, for example, 2x minus 3x minus 2? Do you think so? Okay, the skill for you to factor this will make you very impatient in showing the work this way. It's not natural. It's not natural. Okay, so it's just basically not you. Even when I grade it, I just like, no, that's not natural. Even if that's right, I can tell you're actually cheating from that photo math. And then actually I check with my own photo math. It turns out that person copy paste whatever they see there. It's just like, dude, even if you want to cheat, this is not the way. Okay, this is not the way. One of the big problem with photo math is this: photo math will write multiplication this way. Okay, and the x also looks the same. You're in college algebra. You don't say 2 times x this way. You don't say it this way. That's my 2 times x, Thomas. That's the way I write it. Okay, why? It's so not natural. You're in college algebra. Nobody write it that way. Okay, how do I know which one is x, which one is multiplication? Huh? Right? Okay, but Thomas, my multiplications is smaller. Yeah, but the things your x also small. Come on, man. No, don't need to argue with me for that. Okay, no need to argue with me for that. No, you are feeling that you are actually cheating. Okay, actually, one of you cheat like at least 8 problems. I was very disappointed with like, hey, you know what? Especially one. Do you know that one student in this class called me dirty professor? And that person actually one of the person who cheat. Oh, make me really disappointed. It's not like mad. I'm not mad. It's like disappointed. You want me to be clean? You clean. You be clean yourself. Oh. Anyway, coming back. Now, we have right now a parabola. Okay, I try to explain to you the benefit of having x-intercepts. You see that the axis of symmetry is always the midpoint of the x-intercept. Well, axis of symmetry make the parabola foldable right in the axis of symmetry, right? Okay, so you see that this axis of symmetry here is actually the midpoint. You can find the axis of symmetry as the midpoint of x-intercepts. Are you with me? The midpoint of axis symmetry, the midpoint of x-intercept also gives you the axis of symmetry. So one way to get the axis of symmetry, one way to get that, if you already have your x-intercepts, the x equals to x1 plus x2 over 2. Okay, so in this case, you will see the axis of symmetry is 2 plus square root of 6, that's for x1, plus 2 minus square root of 6 for x2, all over 2. So that will be the square root of 6 cancels, right? So you get 2 times 2 over 2. So x equals to 2. Okay. So to get to get axis of symmetry, one way to do that is to get the midpoint of x-intercept if you have x-intercept at the beginning. And actually, this is one way. There's another way to do it, a faster way. The following. Notice that our x12, if we use quadratic formula, by quadratic formula, our x-intercept is negative b plus minus square root of d over 2a. See, right? By quadratic formula. Suppose you have fx equals to ax squared plus bx plus c. We will see this later on in the next question. So if I play around, our x1 will be negative b plus square root of d over 2a, and my x2 equals to negative b minus square root of d over 2a. When I add them, You see negative b plus square root of d over 2a plus negative b minus square root of d over 2a. Do you notice that the square root of d cancels? Do you notice that square root of d cancels? If I add the zeros, right? Okay, so I end up with negative 2b over 2a. Now the thing is, the axis of symmetry is the midpoint of those zeros. Okay, so it's basically 1/2 times negative b over 2a, right? So we can use this formula. Axis of symmetry is given by negative b over 2a if you have general form. Okay, but if you think about it, actually, you don't need to find the axis of symmetry this way. You don't need to find axis of symmetry this way. Why? You already know the vertex, right? You already know the vertex. X equals to 2. Right? The vertex is 2 comma negative 3, right? Okay, so the axis on symmetry must be x equals to 2, which we confirm here. Okay, which we confirm there. So let's continue down here. If the question were, what is the axis of symmetry? Because we have standard form, so we know the vertex, therefore we know the axis of symmetry by just looking at that. In fact, we know the vertex too. The vertex is 2 comma negative 3. So the range will be, we know it opens up, right? 2 comma negative 3. So the range will be starting from negative 3 to infinity. Okay, so the one on the right hand side here is my scratch work. Some explanation about the axis of symmetry. Now then, how about the graph, Thomas? Let's see, give me a sec. I need to grab my graphing paper. How do I graph that in detail? How do I graph that in detail now? My vertex is negative 2 comma negative 3. That's my vertex. My axis of symmetry is x equals to 2. Okay, my y-intercept is 0 comma negative 1. Now then I need you to get me more coordinates, whatever coordinates of this function that fit into this graph. Okay, now remember that we have that 1/2. We have that 1/2 x minus 2 squared minus 3. Now what is the importance, what is the significance of this 1/2? It will shrink the graph by a factor of 1/2. So supposedly when I move left, right 1 unit, I'm supposed to go up 1, right, for x squared. But because of that 1/2, I go up only 1/2 on the left, right. When I go 2 units to the right, I'm supposed to go up 4. But because of that 1/2, I go up only 2. Actually, the left-hand side confirmed that. When I go 3 units to the right, I'm supposed to go up what? Supposed to go up 9. Okay. But because of that 1/2, I go up only 4.5. By symmetry, I get here. Okay, when I go left, right 4 units, I'm supposed to go up 16, but because of that 1/2, I only go up 8. So 3 plus 5. So the parabola looks like this. Okay, I need you to give me at least this coordinate. Okay, and if you don't have graphing paper, if you don't use graphing paper, I require you to write the coordinate down. So you need to write this one is 4, -1. This will be 3, -2.5. This will be 2, -3. You see what I mean? If you don't have graphing paper on your test, you write it on the blank paper. Okay, then you need to write that down. Okay, you need to write this coordinate down. So imagine if, again, imagine if you don't have graphing paper, that's what it's supposed to look like. Okay, with the x-axis and the y-axis. So your x-axis should be somewhere here, and then your y-axis should be here. Okay, so that's what it's supposed to look like. If you don't have graphing paper, you need to give me the coordinates. Okay, but if you actually use a printout, then you don't need to put the coordinates, but you still need to kind of like make the coordinate thicker here. Okay, make it thicker like that. That's what I want to see. Okay, now let's go back to that function where the original one we have fx.
Professor.
Yes.
Real quick question.
Mhm.
Would there be any point where we had to convert like the certain formula to another one? Like if we had the general form, do we have to convert it to the standard form? Like would there
Yeah,
be a
I will do that later.
Oh, okay.
I do it later. Okay, let's see the case that we supposed to have earlier first. 1/2 x minus 2 squared plus 3. That's what we have earlier, right? Okay, so the first question, what is the domain?
-3.
No, I change it back to +3.
Oh, okay.
Okay, that's the original we have. The y-intercept, as you have seen earlier, you'll find f0, blah, blah, blah. You will find that's equals to 5. So this is 0, 5. Now the thing is, how then do we find the x-intercept? You will see that we will get stuck somewhere. And, well, because we know that we should not have any x-intercept with this. Again, the graph of this will look like what? The vertex is 2, 3. And it will open up. So we should not have x-intercept. Right? We should not have x-intercept. But how will we be able to show that algebraically? Well, you will see that if I subtract by 3 and then multiply by 2, I will get something squared equals to a negative number. Right? If I proceed further, you will get plus minus square root of -6. You see what I mean? But this is imaginary number. This is imaginary number. Okay? That's complex number. Non-real. And because it is non-real, then you cannot put it on the coordinate axis. Okay? Not real. So you will say no x-intercept. Okay, but you will see that this graph will still have vertex. okay, it will still have axis of symmetry. Now, how do we get the axis of symmetry? Well, from the transformation. You see, 2, 3, right? That's the vertex. Okay, so the axis of symmetry will be, we still have it, x equals to 2. Part E, the vertex is 2, 3. The range is from 3 to infinity. It does not include 0, therefore it doesn't have x-intercept. And then when we graph that, we follow the same procedure. That's the vertex, left, right, up. Left, right, 1, supposed to go up 1. I go up only 1/2 because of this 1/2 here. Left, right, 2, supposed to go up 4. Divide by 2 becomes only go up 2. And now you can confirm that your y-intercept is 0,5. Right? Okay, then left, right, 3, go up 9, but because of 1/2 becomes 4.5. Oh, it's already outside the curve, so I can stop there. Okay, so notice that even if we don't have x-intercept, we still have the vertex. Okay, we may have that situation. Even if we don't have x-intercept, we still have the vertex. Okay, we still have axis of symmetry. Okay, so to find axis of symmetry, one way you get the midpoint of x-intercepts. But what if you don't have midpoint of x-intercept? Well, if it is standard form, then the axis of symmetry is right in front of you. Okay, and therefore you will get the vertex now. If you have general form, I recommend you to use formula instead to find the axis of the axis of symmetry. Okay, let's tackle that kind of question. Suppose, for example, let fx equals to, I make it -1/2 right now, -1/2 x squared, and then plus minus 3x. That's good. And then plus, let's say, make it +2. Make it +2. I don't know if that will give me a nice number or not. Make it +2. Will that be good? Maybe not 2. Make it plus 3/2. Okay, so part A, what is the domain? As usual, the domain will be all real numbers for polynomial, right? Okay, how about the y-intercept? For here, because it's in general form, the y-intercept, you basically look at the constant. That's 0,1.5. How about the x-intercept? Every time you solve for x-intercept, the first thing you do is set the y equals to 0. And then from there, solve it the way you learn it in chapter 1. So I multiply by the LCD 2. I get 0 equals to -x squared minus 6x plus 3. Oh, you know what? Let me multiply by -1 now, x squared plus 6x minus 3. And then from here you solve it because the leading coefficient is 1, and then the coefficient of x is even. I may just use completing the square. So I will add 9 to both sides to complete it. So I get 12 equals to x plus 3 squared.
Wait, why did you flip the sign?
Flip what sign?
Where it said like you flip like the negative x squared minus 6x plus
Oh,
3.
because when we deal with standard form, I feel more comfortable if my leading coefficient is positive.
Okay.
This one here, right? Why I make
Yeah.
it positive, right? Because I feel more comfortable when I solve an equation when the leading coefficient is positive.
So when we flip that, we have to flip everything else too?
Yeah, of course, because what we do there is basically we multiply by -1.
Okay.
Right? Okay, but you can just use the formula right away if you prefer to use quadratic formula. Yeah, as long as it is not factorable. If it is not factorable, then you are free to use quadratic formula or completing the square. Now the thing is, if I want to do completing the square, my leading coefficient has to be 1, cannot be -1, right? Oh, by the way, another option is actually move everything to the left. Right? You add x squared, you add 6x, you subtract 3, right? So you see, you basically get the same thing here, but on different sides. Okay, let me continue. Then I apply the square root property. So this is x equals to -3 plus minus 2 square root of 3. So my x-intercepts are -3 plus 2 square root of 3 and comma 0. And then -3 minus 2 square root of 3, almost 0. Now then, how about my axis of symmetry? There are two ways to do it. The first one, x equals to -3 plus square root of 3 plus -3 minus 2 square root of 3 over 2. Now you will see what happened is this. You will see that the irrational part will cancel. The conjugate part will cancel. Okay, and then you get -6 over 2, that's -3. Okay, so I write it as an equation of a line, x equals to -3. And how about the vertex? Oh, that's the first method. The second method, I think, is easier, is you look at the original function. The b, the formula is -b over 2a. That's -3. So x equals to -3. That's to get the vertex. Sorry, axis of symmetry. Part A, how to find the vertex. The x component of vertex already known. It must be the same to the axis of symmetry, right? But how about the y part? Then the y part, you plug that x into the function. Is it minus or plus? I don't want to copy the function incorrectly. Okay, so that's the function. So I've now plugged in x equals to -3 into the function. So I get -1/2 times 9 plus 9 plus 3/2. That is -9 over 2 plus 9 plus 3/2. That's -6, huh? -9 plus 3 is -6, right? That's -6 over 2 plus 9. That's -3 plus 9. That's 6. So the vertex is -3, 6. Now from there, then you can tell what is the standard form. Oh, what is the range first? Notice that the leading coefficient is negative. Okay. And therefore, the range is, the parabola is upside down. Right? So the range will be from negative infinity up to the y. Now from there, I go on. Let me copy that here. The vertex was what? Vertex was negative 3,6, right? So what is the standard form? The standard form is fx equals to a times x minus h squared plus k, where the hk is the vertex. And the a is what? The a is the leading coefficient, right? The a is the leading coefficient. The h is the x component of the vertex. The k is the y component of the vertex. Now we are ready to graph it. Yes, that's right. But you forget the square, Joshua. Yeah. So let's graph it. The vertex is negative 3,6. Negative 3,6 is here. It's upside down with leading coefficient negative 1/2, which means when I go 1 unit to the right, supposed to go up 1. I go down 1/2 instead. Likewise, when I go to the left. When I go left, right, 2 units supposed to be square, it becomes 4, but the negative 1/2 becomes negative 2, down 2. Okay, left, right, 3 units supposed to go up 9, divide by 2 becomes go down 4.5. So now you can confirm that your y-intercept is 0, 1.5. Right, left, right, 4 units, square it 16, because of negative 1/2, I go down 8. Okay, so the graph will look like this. Okay, and on the top of that, don't forget we have axis of symmetry to put the details on. Okay, that's for basically that's for this section. Now let me ask you to spend maybe like around 5 minutes to do the following question. For example, example 3. Example 3, let fx equals to 1, maybe just keep it 1/2, maybe negative 1/2, then negative 1/2 x squared minus 3 over 2x plus 2. You can easily find the domain and the y-intercept. So you can do it super fast for that one. You may have issue, you get slowed down in the x-intercept. That should take you approximately 2 minutes. Okay, and then part D, I need to find the axis of symmetry. I think the axis of symmetry will not be that nice. And then part E, find the vertex. But once you are done with the axis of symmetry and vertex, you are actually ready to do part F, which is the range. That's very quick. And the standard form. That's the function. And then finally, I would like to graph it. Okay, let me give you maybe 6 minutes from now. Right now it's 11:54, 6 minutes at 12 o'clock. Okay, please do that. Okay, let's see. What's the domain? That's polynomial, so it should be all real numbers, right? Okay, the y-intercept is 0, 2. The x-intercept, this is where we get some issue. Let me give myself more space. Usually we have issue here. So 0 equals to negative 1/2 x squared minus 3/2 x plus 2. I will multiply by negative 2. Is it okay? So multiply by 2 to get rid of the denominator, and multiply by negative to get rid of the sign, negative sign in the leading coefficient. So I will get 0 equals to x squared plus 3x minus 4. Hey, hold on. I think this is factorable, huh? Do you think so? So then you need to factor it. Oh, that's fast. So x1 is negative 4, x2 is equals positive 1. So that's negative 4, 0, 1, 0. Oh, that's nice. Axis of symmetry. Well, because I have nice x-intercept, let me just use them. So x equals to negative 4 plus 1 over 2, then that's x equals to negative 3 over 2. Now, if you use formula, you should get the same answer. Negative b, which is negative 3/2. Right? My b is negative 3/2. Okay, over 2a. So x equals to, there are 3 negatives, so it will be negative 3 over 2 at the top, 1 at the bottom. So x equals to negative 3/2 anyway. The same to what we get earlier. But the vertex, then I need to plug in the x component of my vertex, which is known to be from axis of symmetry, okay, into the function negative 1/2 x squared minus 3/2 of x plus 2. This will be negative 1/2 times 9 over 4 minus, no, this is plus 9 over 4 plus 2. This is negative 9 over 8 plus 18 over 8, I do LCD, plus 16 over 8. That will be 25 over 8. That is the y component of my vertex. Let me start putting it in. So the vertex will be negative 1.5, comma, 3 and 1/8, slightly more than 3. So it's approximately. Oops. Okay, when I go, and then what is the y-intercept? That should be helpful. My y-intercept is 0, 2. Okay, so this one here must be symmetric, right? Okay. When I go 1 unit to the left, right from this, when I go 1 unit to the left, right, I will go down 1/2. Okay, and then my x-intercepts are 1, 0, -4, 0. Okay, and then when x equals to 2, just start plotting numbers then. When x equals to 2, what happened to the coordinate f2? I just want to get more coordinates. -1/2 2 squared minus 3 times 2. I'm sorry, 3/2 times 2 plus 2. This is -1/2 times 4 minus 3 plus 2. That's -2 minus 3 plus 2. So when x equals to 2, it will be -3. By symmetry, then it must be -3 also here. So the graph will be approximately looks like this. I don't expect you to be able to do the graph super smooth, but at least you plot the coordinates, important coordinates at its place first. Okay. Okay. Oh, we get the vertex. So how about the range? The range will be from -infinity up to 25/8. And the standard form fx equals to -1/2 x plus 3/2 squared plus 25/8. Okay, and that's the graph. Okay, I hope that's okay. Would you like more questions here? This type of question for sure will be in your test. For sure will be in your test. Trust me. It's in your quiz because it's important. Okay, and for sure it will be in your test. One more. Okay. Let's see. For example 4 right now, I guess. Let fx is equal to maybe 3/2 -3/2 x squared plus x minus 1. Make it +1. So part A, the domain, it's easy. The domain of polynomial, in this case including quadratic function, must be all real numbers. Second, how about the y-intercept? That's 0, 1, right? That's easy to see. When x 0, then you get the constant. Part C, how about the x-intercept? Once I set the fx to be 0, then I will see quadratic equation. Then how to solve quadratic equation? You have factoring, completing the square, formula. But even if you want to use formula, get rid of the fraction first. Okay, so let me multiply this by -2. Okay, so I get 0 equals to 3x squared minus 2x minus 2. I don't think that's factorable. Yeah, I don't think that's factorable. Is it? No, it's not factorable. Well, let's see. To check if it is factorable or not, let's do the discriminant. B squared minus 4ac. That's 4 plus 24. Yeah, it's 28. It's not a square number. Square root of d is square root of 28, which is 4 times 7. Okay, so x12 will be negative b plus minus square root of d over 2a. So x12 equals to negative 1 plus minus 2 square root of 7 over 2. So my x-intercepts are negative 1 plus 2 square root of 7 over 2 comma 0, negative 1 minus 2 square root of 7 over 2 comma 0. That's for the x-intercepts. For the axis of symmetry, I can use formula x equals to did I put the wrong number in there? Ah, thank you. Thank you. I make a very big mistake in my computation. Actually, no, my mistake is, oh, no, I'm actually right. My B is negative 2. My A is positive 3. Now, I see. Okay. My B should be, I look at the wrong one. My B should be, thank you though. Let me use red color to correct that. My B should be negative 2. So this should be positive 2. Oh, I need that. Thank you. That's positive 2. Let me fix it first. So I can factor the 2 and cancel it. Okay. Good thing I detected early. You will see later on, if I don't detect that now, I will detect this mistake later anyway when I put them in graph. I will explain it later on. Okay. At least you saw earlier that I have negative 1/2 plus minus 2 square root of 7 over 2. This is wrong, right? This is wrong. That's wrong. Thank you. This is 3. This is 2 times, so this is 6 here. So this will be over 3. Thank you. Here's the thing. Notice that earlier I get this. So you will see if you have irrational part, you will see your axis of symmetry will be this part. You still need to show me the work though. Okay. Now you will see that if I use my formula, I will not get that one, and that's how I will detect I make a mistake earlier. Okay. So so imagine if our friend didn't tell me this. Imagine if our friend didn't tell me, Thomas, your denominator supposed to be 3. Okay, let me show you. Okay, suppose I leave my answer like that. Okay, we know this is wrong. Okay, we know this is wrong. But suppose I don't detect that right now. I go on further. So I just leave it there. Okay. Then from here, I use the formula. X is negative b over 2a. There are two negatives, so it's positive. On the denominator, I get 3. Okay. Then from at this point, then I realize something not right with my x-intercept. Okay. Why? Why? Because this part here, the rational part, should be 1/3. The rational part should be 1/3. Okay. So even if you don't tell me earlier that the a is supposed to be 3, Thomas, you make mistake with the denominator, right? Suppose you didn't tell me earlier, I will detect that anyway. That's why that's the need of showing work properly. Okay, if you don't show your work properly, you won't be able to detect that. That's first. Even if you see there must be a mistake, you don't know where's the mistake. Okay, now with me showing the work properly, I will be able to say, oh yeah, that's right. That is supposed to be, the a is supposed to be 3. You see what I mean? That's the importance of showing work properly. Okay, going further. How about the vertex?
Professor, I have a question.
Uh-huh.
How did the 1 plus a negative square root of 7 happen?
I factor the 2 on the top. So what we have here was 2 plus minus 2 square root of 7 over 6. Now you see on the top have common factor 2, right? So if I take 2 out from here, you have only 1 left. If I take 2 out from here, you get square root of 7.
Oh, got it. Thank you.
Okay, so common factor 2. Then how to find the vertex? Now we already have the x component of the vertex, which is 1/3. Then just plug that into the function. Okay, so f1/3 equals to negative 3 over 2 times 1/3 squared plus 1/3 plus 1. Negative 3 half times 1/9 plus 1/3 plus 1. So this will be negative 1/6 plus 1/3 plus 1. That will be 7/6. That's 7/6. Now then, I'm plugging. Let me look at the graphing paper. What is the vertex again? 1/3, 7/6. Oh, the number is so ugly. 1/3, 7/6. You know what? Let me do this. I enlarge that. So 1/3, 7/6 approximately here. Now the y-intercept is 1. It should be that. Okay. The x-intercept we don't know, but what happened when x equals to 1? When x equals to 1, I get 1/2. When x equals to 1, I get 1/2. So by symmetry must be 1/2 also here. No, it's not there. It's not symmetric there. And then just plot the more coordinates, and when x equals to 2, what happened? X equals to 3, what happened? Okay, when x equals to 2, let's see what happened when x equals to 2. Negative 6 plus 3, negative 3. X equals to 2, that's negative 3. So it will look like approximately like this. It's actually quite skinny. When I write the test, I will try to have the vertex right at the nice coordinate. This one is very, very ugly coordinate, so nearly impossible for me to graph it nicely. For example, this one should be here. This one also. So it should be here. Yeah, you stretch that by factor of 3/2. So the standard form will be fx equals to negative 3/2 x minus 1/3 squared plus 7/6. That's the standard form. Okay, now that's basically it for this 3.1. Let me go on to 2.4 in the next 20 minutes. I only have 15 minutes actually, but I have to cover this. 2.4, I call that part B, the piecewise defined function. The idea is actually very simple. Piecewise defined function piecewise defined function is a function, just by its name, a function that is defined piece by piece. Okay, I give you a simple example first, just as an introduction. Example 1, let fx equals to 2 for x less than equals to, let's say, 1, and then negative 3 for x greater than 1. Now, when we say piece by piece, it is basically as the following. Notice that the domain is being, they actually make it into 2 pieces. The one to the left of negative 1, including negative 1, that's the first piece. And greater than 1 is the second piece. That's the second piece. Okay, so when x is 1 or less than 1, the function you use is fx equals to 2. And when x is greater than 1, the function you use is fx equals to 3. I'm sorry, negative 3. Okay, so how do we graph that then? What will the graph look like? When x is less than or equals to negative 1, less than or equals to 1, the function is 2. So the function is 2. Fx equals to 2 is a horizontal line, right? Okay, so from here, do I include the endpoints, by the way? Yes, I do, right? Because that's x less than equals to. Okay, so I include the endpoints. So I make it thicker here. Now, from 1 to infinity, fx equals to -3. Okay, so from 1 to infinity, it is -3. But right at x equals to 1, it is not. So I use open circle here. But then it will be a constant function fx equals to -3 to the right-hand side. Okay, that's basically the idea. When we say piecewise defined function, means it is defined piece by piece. Now, let's say we do more. Let's say we do more. This time we make it a bit more complicated. Let's say fx is equal to x plus 1 squared for x less than 0 and 2x minus 1 for x greater equals to 0. You see, so on this piecewise defined function, the cut point, you cut it at 0. To the left of that, not including 0, the function applies in this domain here will be x plus 1 squared. While the one to the right and including 0, the function applies there is 2x minus 1. So let's graph it. To the left of 0, you will graph x squared, x plus 1 squared. So that's a parabola. Okay, that's a parabola. Vertex as -1, 0. Okay. So it looks like this. But I stop at 0, not including x equals 0 because of that domain. Now at 0, including 0 to the right, you will use 2x minus 1. Now 2x minus 1 is a line with y-intercept 0, -1. The slope is 2. So then the whole graph will look like this. The whole graph will look like this. Maybe for my circle here, I can make it better. It's an open circle. Okay, that's what it looks like. Maybe one more question. Example what? I pick question from the book now. Example 3. Example 3, 2.4 number 60, fx is equal to 1 minus x minus 1 squared for x less than equals to negative less than equals to 2, and square root of x minus 2 for x greater than 2. The graph for these, the graph for square root of x minus 2, the domain is, this is actually square root of x that you move 2 units to the right. Is that right? Okay, that's square root of x that you move 2 units to the right. Okay, so it happens to coincide with these, but I should not include the endpoints. So I should not include the endpoints. Okay. Let's try to sketch the graph. Okay, so the starting point is 2, 0, but not including the endpoints. And then I do the movement of square root of x, up 1, right 1, up 2, right 4. So it will look like this. Then how about the one on the left? 1 minus x minus 1 squared. You may not be able to see this clearly, but let's rewrite this. This is negative of x minus 1 squared plus 1. Now, can you tell me what's the vertex now? What's the vertex? 1 comma, I don't think so. I think it's 1 comma 1. Yeah, I think it's 1 comma 1. Right? Yeah, 1 comma 1. So the vertex is 1 comma 1, opens up or down. Opens down, right? Okay, and the leading coefficient is negative 1. So basically we flip that upside down. So from here, I move left, right 1 unit, go down 1. Oh, that coincides, so it becomes, okay, feel it. 1, 1. When I move left, right 2 units, I go down 4. But the thing is, I should not have anything here, right? So go down 4. Yeah, basically it. Okay, that's what it looks like. Now the thing is, why I need to do 3.1 first before I do this? Because we cannot graph this without 2.5. Without 2.5, you won't be able to graph this. Well, you can graph it by plotting the coordinates, but it will take forever. Okay, that's why I prefer to teach 2.5 and then 3.1 and then come back here. Because at this point, you know how to graph. Now you just do it piece by piece. Okay. Suggested homework from this one section here. From 2.4, suggested homework. I would like you to take a look on number 57, 59, 60, 63. And then for 3.1, for 3.1, suggested homework. I need you to do number 7 to number 11, and then number 17 to number 29. 17 to number, maybe up to number 20, 25 is good enough. And then also try the finding the function, number 43 and number 45. And then the fast one, 47 to number 53 is good enough. Okay, that's all for today. See you then on Tuesday. Don't forget, next week we have a test. Okay, and you need to get prepared with your Zoom. Okay, I will need to proctor you. Thank you.